Well, hello again. So here we are. Ms. Pender just got done helping you to learn about division by the synthetic method. That's what it's called. And the reason we've been doing this stuff is so that we can solve equations that are of power higher than 2. So we know how to solve linear equations like 2x plus 1 equals 11. That's easy. And we know how to solve quadratic equations. We can either factor them or use the quadratic formula. But sometimes we have equations that are higher than degree 2. The power is higher than 2, such as 3 or 4. We're going to look at those today. And this is going to be part 1. There's actually another way to solve these, some more complicated ones. And we'll look at those in part 2. So I want to start you off with something that you already know, as we often do. So we want to solve x squared minus 25 equals 0. So of course you remember that this is representing, or is the structure of the difference of squares. So we have a perfect square here, we have a perfect square here, we're subtracting, so this is obviously the difference of squares. And hopefully you remember that the way to factor the difference of squares is this little method right here. We take the square root of the first thing, we take the square root of the second thing, and we do a plus and a minus. So that's what we're going to do. So we're going to do square root of x squared, of course, is just x. Square root of 25 is just 5. We'll put a plus, and we'll put a minus. That's how to factor. And we got equal to 0. And then our solutions come right out of here. So what number makes this thing here 0? So negative 5 plus 5 makes it 0. It's just another way to think about that is just flip the sign. And same thing here. We'll just flip the sign, and there we have it. Negative 5 and positive 5. And for those of you that are cool, like Ms. Pender and I, you could write plus or minus 5. So this is the difference of squares because these are, well, squares. Not surprising to you should be that we also have a formula for the difference of cubes. The difference of cubes formula, however, is more complicated than this one right here. And there it is right there. So when we have two things that are being cubed, so we have a first term that's being cubed and a second term that's being cubed, with a subtraction sign in between, we have this cool little formula right here. So all we need to do is figure out what's being cubed, that's A, and the second part that's being cubed, that's B, that goes into this little parentheses, this first binomial term right here. And then the rest of it is going to be this thing here, the A, squared. The product of those two, A times B, right here, with a plus sign. We're going to talk about the signs in a minute and how you can remember them. And then the last term here, b squared, is just going to be this one squared. So this is our formula. Every time we have a cubed minus b cubed, the difference of cubes, this is our formula every time. So you may recognize that there are several signs for us to have to worry about here. Here's 1, 2, 3 signs. And you got to figure out, what's going to be positive, what's going to be negative. And we have this little device for you. It's called SOAP. And in the age of coronavirus, we know a lot about soap, and we use soap a lot. Or at least I hope you're all are using soap a lot. So S, in this case, stands for same, as in the same sign as that one right there. O stands for opposite. So if this is minus, that one's going to be opposite of that, plus. And AP stands for always positive. The last term, or the last sign, is always positive. So this sign is the same as this one, S. This sign is the opposite of this one, O for opposite, and this sign is always positive. So this is a way of helping you to remember the signs that go with this formula. And again, this is just A minus B. Take the A, take the B, put them in there, square the A, square the B, multiply them. We're going to use this formula several times today, obviously. And we wouldn't want to have just the sum of, or the difference of cubes. We also have the sum of cubes. We don't have that for the sum of squares because we end up with imaginary roots, and that's okay. And we also are unable to find two numbers that multiply to make 25 and then add together to make 0. So that's where the middle term has gone away, the 0x. So, but with different, or sum of cubes, we actually have the opportunity to be able to do that. So again, it's the same formula, only different signs. And here SOAP comes in again. So remember, the first sign is going to be the same as this. The second sign is going to be the opposite of this, and it is, it's minus. And the last sign is always positive. So let's jump into an example. So here we have x cubed minus 27. So the first thing we need to do is figure out, well, whether this is the sum or difference of cubes. Let's check it out. So x cubed, well, that's obviously a cube. 27 is, well, also obviously a cube because 3 to the third power is 27, and that's a minus sign, so this is obviously the difference of cubes. That means we get a chance to use this formula right up here. So in order to use this formula, we need to know what a and b are, and that's pretty simple. This is something cubed, so this is what a is. This is a cubed. So from here, we can figure out that a must be x. So a is x. And from here, all we need to do is take the cube root of that, just like over here we took the square root because this was the difference of squares. Here we're going to do the difference of cubes, so we're going to take the cube root. So the cube root of 27 is 3, and that's going to be our b. So a is x, b is 3, and now we just take these guys, put them into that formula using those signs. So we got a minus b. I'm just going to write the formula right here. So a minus b times a squared plus ab plus b squared. Now let me know what a and b are. We just plug them right in. A is x, so we put an x there. B is 3, put a 3 there. Square the a, well that's the a, so square it, x squared. Multiply the two things together with a plus sign, right? Remember, SOAP takes care of the signs. It doesn't matter what these things are, what the x is and what the sign of the x is and what the sign of this thing is here. It doesn't really matter. We are always going to write a plus sign right here, every time. And then we multiply them. So x times 3 is just 3x. And then, squaring the b is 3, squaring that, we get 9. And we're done. This is factoring using the difference of cubes. Okay, so let's take a look at another one of these. So here we have y cubed plus 64. So remember what I said, we can also have the sum of cubes. We don't have to have just the difference of cubes. So it is exactly the same. So we have the same formula, we just need to figure out what a and b are. Well, in order to find a, we take the cube root of that. So a is y. In order to find the b part, we're going to take the cube root of that, which is 4, and then we're just going to plug them right into the formula. Then I'm going to write the formula again. So we got a plus b, in this case, because this is the sum of cubes, times a squared minus ab plus b squared. I was hoping that our friend the stink bug would come by again today, but no stink bug today. All right, so we got a plus b, so a is y, b is 4, so we got y plus 4. And then we have squaring the a, and a is y, so we get y squared. And this is a minus sign, remember, because it's always the opposite of that. So we multiply a times b. A is y, b is 4, so we get 4y, plus b squared, and b is still 4, so we get 16, and we're done. Interestingly enough, when we do this, this piece here is never going to be factorable, assuming these are simplified and these are lowest term cubes and there was no common factor to take out. Okay, so let's get a little more complicated here. So instead of just having a variable cubed and a number, we can also have a variable cubed with a coefficient, a different variable cubed, and a different coefficient. But it's all the same. It's still the same formula. So we still got to find a and b. So in this case, a is going to be the cube root of this, and of course the cube root of 8 is 2. The cube root of x cubed is x, easy enough. B is, well, the cube root of 125 is 5. Cube root of y cubed is y. So we just plug them into the formula. So this is a difference of cubes, so we're going to start with 2x minus 5y. And then square the a, that's that right there, so we're going to square that, so that's going to be 4x squared. And this is a minus, so we always go opposite. Remember, SOAP. So we do plus here, and then we multiply these two guys together. 2x times 5y is 10xy. And then we multiply or square this guy right here. It's always positive. So 25y squared. And that is all he wrote. Okay, so you try it. Same thing here. So we have a coefficient and a variable cubed. We get another coefficient, variable cubed. You know the drill. Make sure you do the push-ups, and we'll be back in a moment. Okay, so you've had time to do your push-ups. So we're just going to rip right through this. So the cube root of 27 is 3. Cube root of that is x. We got a plus. Cube root of that is 4. And we got a y. And then we square the first thing, 9x squared. Write the opposite sign. Multiply those two guys together. 12xy. Square that. 16y squared. And hopefully that's what you got. Okay, so let's take a look at this guy right here. So you may think, all right, well, 216, is that a perfect cube? Well, I'm going to tell you it is perfect. It is a perfect cube. And we can go through the perfect cubes. So 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 is 27. 4 cubed, 4 times 4 is 16 times 4 is 64. 5 cubed, 5 times 5 is 25 times 5 more is 125. And 6 cubed, 6 times 6 is 36 times 6 more turns out to be 216. So this is a perfect cube. But now let's take a look at the x to the 6th here. Is that a perfect cube? And so the way to figure out whether this is a perfect cube or not is to take a look at the exponent and say, is that divisible by 3? And the answer is, yeah, it is divisible by 3. So x to the 6th is really, I'm going to use a little space up here, x to the 6th can really be written as x squared cubed. So this thing here really is a perfect cube. It's a perfect cube. And the same thing goes for right here. This is y to the third, and it too is a perfect cube. So since these guys are perfect cubes, we can apply the formula. So as we've already talked about, the cube root of 216 is just 6. And the cube root of x to the 6th is x squared. Right? We're just going to divide that by that exponent by 3. So 6 divided by 3 is 2, so we get 6x squared. And then we have a minus. And then we're going to take the cube root of y to the 9th. So again, just divide the exponent by 3. So we get y cubed. So there's our a, there's our b, and then we just do the rest of the formula right here. So we're going to square that. So that's going to be 36x to the 4th. Don't forget to square that one also. And then that's a minus sign, so this is going to be a plus sign. It's the opposite. And then we're going to multiply these two guys together. So 6x squared y cubed. 6x squared y cubed. And then lastly, we're going to just cube this guy right here. Square this guy right here. So we're going to have plus y to the 6th. So it looks a little complicated, but it wasn't very difficult at all. Okay. So you try right here. Same kind of problem. But I am going to give you a little bit of hint on this one because this one is slightly trickier than the previous one. If you'll notice, the 5 right here, actually, I'll start you off and you're going to finish. How's that? So you'll notice here that the y to the 5th, that's not a perfect cube, and y to the 8th, that's not a perfect cube. But they do have something in common that might help us to get to a perfect cube situation. So we can see if we take 2 y's out of here, we'll have a y cubed. If we take 2 y's out of here, we'll have a y to the 6th, and those guys will be perfect cubes now. And we see that 54 and 250, we could take a 2 out of here to make a 125, and a 2 out of here to make a 27. So then those will be perfect cubes. So what I'm saying here is we're going to factor out a 2y squared out of both of these guys right here. And then we'll end up with this bit. 125y to the 3rd minus 27y to the 6th. So please take a moment, do your push-ups right here. So we've already factored out the 2y squared, and now what I'd like you to do is factor out, or factor this using the difference cubes. Okay, So hopefully you did that. And so we got 2y squared. And then we're going to do the cube root of this, which is 5y. And then we're going to do the cube root of this. I think I should have used two variables here, but it'll work just fine. Cube root of this is going to be negative 3y squared. And then we do the rest of our business right here. So we square this, so that makes 25y squared. Opposite sign, so we get a plus. And then we multiply these two guys together, so we get 15y to the third. 15y to the third. And then we have a plus because it's always positive, and we square that, 9y to the fourth. And there we have our factoring. That includes a greatest common factor and the difference of cubes. All right, so the reason we do all this factoring stuff is so that we can do some solving. So let's do some solving using the difference of cubes. So let's take a look at this one right here. And I'm going to do it incorrectly first because I want to illustrate a point here. So we'll do that in red. So let's do this right over here. So some of you may be seeing this and saying, hey, x cubed minus 64 equals 0. Can I just add the 64 over? Sure, let's take a look and see what happens. So we get x cubed equals 64. Then we ask ourselves, well, what number times itself 3 times makes 64? Or what number cubed makes 64? Well, the answer is 4. So at first, this appears to be that the answer is x equals 4. But when we go back and do this the right way, we see that there's actually more answers than just this one. Because as we've gone over several times in class, if we see that the equation is cubic, we know that there should be 3 solutions, and this is only 1. It means we're missing 2 solutions, and let's see where they are. All right, so we're going to factor this using the difference of cubes. And so we take the cube root of that, which is going to be x. Take the cube root of that, which of course is 4. So that's easy enough. And then we square that, right? Just using the formula that we've been using all along here. Plus, multiply those two, we get 4x. And then square that, we get plus 16. And that's all still equal to 0. So we take a look at this piece right here, and this is easy enough. Just flip the sign and we get 4 for one of our solutions. But then we see this thing over here. And we realize that this is a quadratic equation, power of 2, right? Quadratic equation. That means we got 2 more solutions here. So there's 1 solution here, plus the 2 out of here makes the 3 that we were expecting. And now let's see if we can figure out what the solutions are for this. And we try to figure out, well, whether can we factor this? That's the first thing we should try. So are there 2 numbers that multiply to make 16 and add to make 4? And the answer is no. And in fact, I'll tell you during the rest of this show right here, this is never going to be factorable. You are always going to have to use the quadratic formula. Really sorry to tell you that. So let's jump right into the quadratic formula right here with this one. So here's our a is 1, b is 4, c is 16. So we're going to jump right into this. So we got negative 4 plus or minus the square root of 4 squared, or 16, minus 4 times 1 times 16. All of that is over 2. And that's going to give us negative 4 plus or minus the square root of 16 minus 4 times 1 times 16 is 64 over 2. And 16 minus 64 is 48. So we got negative 4 plus or minus the square root of negative 48 over 2. And of course we remember that whenever we take the square root of a negative number, we have an I. And we also see that 48 has a perfect square that goes into it, and that's 16. And the square, so we're going to write that. So we got negative 4 plus or minus I root 48 over 2. Should have left a little bit more room. Equals, and now we see that the 48, as I said, has a perfect square that goes into it, and that's 16. So we have negative 4 plus or minus I root 16 times 3 over 2. And definitely should have left more room. Negative 4 plus or minus, the square root of 16, of course, is 4. So that's 4i root 3. All of that's over 2. And then we divide the 2 into there, and we have negative 2 plus or minus 2I root 3. That's two of your answers, along with this one up here, to give you the third answer. So what we did here is we factored using the difference of cubes formula, and then when we got to this bit right here, we realized we had to jump through all of the quadratic formula to get to the answer right here. So in the interest of saving time, because we're already at 20 minutes, I'll just kind of do this one fairly quickly. We'll just set up the quadratic formula, but we won't actually do the whole thing. So this is a sum of cubes. It's going to be the same exact show. So we're going to do the cube root of this, which of course is x, and the cube root of 27, of course, is 3. And then we're going to have squaring this, x squared, change the sign of that, multiply those two guys, 3x, square that, plus 9, equals 0. And we have negative 3 here, and then we got to jump through the whole quadratic formula show right here, and I can assure you that, again, we're going to come out with imaginary solutions. And that's the case with this always. We're always going to have imaginary solutions. Because remember back up here, when we tried to do this problem, we came up with just 4. Well, the other two are imaginary, and that's why we couldn't see them. So anyway, that's why we had to go through the quadratic formula. All right, trying to save a little time here, so let's jump over and get to a place where you're going to finish this one out. So again, we look at 2x to the fourth minus 250x equals 0. And what you should recognize here, of course, is that they have a common factor in them. That's 2x. I want to make sure that common factor concept is still there for you all the time. So we're going to factor out a 2x. So we got 2x times x cubed minus 125 equals 0. So right now you're going to pause the video. You're going to do your push-ups. You're going to factor this using the difference of cubes, and you're going to do the whole quadratic formula all the way through. So really, really do that, please. So pause the video, do the work. Okay, so again, hopefully you had the time to do that. So this is going to be easy enough here. This is just going to be 0 because we know that 2 times 0 is 0. So that's easy enough. So that's one of our solutions because remember, we're going to have 4. And then we're going to factor this guy right here. So we're going to have, we're just going to work on this piece because we already know that the 2x gives us 0. So we're going to have x minus 5 times x squared plus 5x plus 25 equals 0. We already know the solution to that one is going to be 5. So let's put this right over here, just trying to save a little space. I'm going to start my quadratic formula right over here. So I'm going to have negative 5 plus or minus the square root of, and again, you've already done this, so I'm just ripping right through this. 25 minus 4 times 1 times 25. All of that is over 2. And we get negative 5 plus or minus the square root of 25 minus 100 is negative 75. There's our imaginary number there in the square root with a negative number. So then we have negative 5. Again, saving time. We're going to have an I with a negative, and 25 is the largest perfect square that goes into that. So we're going to pull out a 5. So we get plus or minus 5I root 3, all of that over 2. And that's as far as we can go. So here are 2 of our solutions. There is another solution that makes 3. And here is our 4th solution right there because this is a 4th degree equation. Okay. All right, here we are at 24 minutes, and I think I'm going to stop right here. We were going to work on quartic equations, quadratic-like, but I'm going to stop right here, and we'll just have an assignment based on the sum and difference of cubes. And either Miss Pender or I will finish up with this on the next time. See you on Wednesday.